Okay, sorry for that interruption. It was an important call from my charter, so I needed to take that. But we're back anyway because you needed to do some OIOs. So let's finish these. I'm going to multiply by the square root of 3, and I get the square root of 3 over 3, and that's finished. No radical in the denominator. Okay, and here I'm going to multiply by whatever's under the square root. So I get, now this 3 is not under the square root. This is under the square root. So I'm multiplying, it's like multiplying an x times a y. They're two different things. So I just write them next to each other. So this becomes 3 square roots of 2, x, over, now this square root and this square root cancel each other, and I get 2x on the bottom. Now, we haven't done it yet, but just be on the lookout. If I have numbers that are outside of the square root, like this 3 and this 2, I can simplify. I'm not going to do it now because 3 and 2, that's not an even simplification, but it's coming. All right, so I hope you understood those. I'm going to switch back to red, or let's do something else. How about blue? Okay, so the second half of our lesson today is we're going to start add or subtract radicals. And there are some rules for this, and we will write them down as we go. So let's start over with number 1, and here we have 4 square roots of 10 plus the square root of 13 minus 9 square roots of 10. Okay? So radicals work very similarly to variables. You can only add or subtract radicals if the radical is the same. Okay, so when I'm looking at this problem, I see that I have the square root of 10, the square root of 13, and the square root of 10 again. So it's just like if I had an x here and an x here. Those I can combine. They have the same square root. So I'm going to reorder them. I can move the 9 here, but be careful. What is the sign in front? It's a minus, so I have to take that with it. So now they're in a different order, and it's easy to see what I need to do. So I'm going to add 4 and negative 9. So that's going to be negative 5. Now my square root doesn't change. Just like a variable, that doesn't change. It just comes along for the ride. So I have 4 square roots of 10, negative 9 square roots of 10. I combine them, and I get negative 5 square roots of 10. And then the square root of 13 just comes along with it. There's my answer. And here is the work you can show. Okay, number 2. The square root, 5 square roots of 3 plus the square root of 48. Okay, now, these initially look like they're different, and they are. But if you can't combine something, check to see if you can reduce or simplify. So I'm going to look here. Can I factor anything out of the square root of 3? No, not evenly. Now I'm going to check, is there a perfect square in 48? As a factor. So is there a perfect square as a factor? Well, I've got lots of factors of 48, so let's write them down. 1 and 48, 2 and 24, 3 and 16, 4 and 6. Okay. Now, which pair has a perfect square? Well, 3 and 16 does, and 4 and 6 does. Which one would I pick? Well, you want to pick the largest perfect square. So that means I'm going to pick this one. So I'm just going to bring 5 square roots of 3 along for the ride. And then I'm going to factor the square root of 48 to the square root of 16 and the square root of 3. Okay? And that's multiplication between them. So now the square root of 16 is 4. So that becomes 4 there. And then it's still multiplied with the square root of 3. Now look at this. Doesn't that work out nice? I just love it when it works out well. Okay? They have the same radical, so I can actually add them together. I've got 5 square roots of 3 and 4 square roots of 3, and I get 9 square roots of 3. And there is my simplified answer. Okay. That's adding and subtracting. Now we're going to do a little bit of multiplying. So I have number 3, the square root of 5 times 4 minus the square root of 20. Okay, so I've got a radical on the outside that is multiplied by both things on the inside. This is the distributive property, and when we think of the distributive property, what do we think of? Cake. Remember eating cake in class and how much fun that was? Maybe you should go have a piece of cake right now in honor of the distributive property. Like, put some icing on it. Distribute icing to cake for your whole family. I'm sure your mother would just love it, and you tell her Mrs. Strickler sent you. No, don't do that. That'll just get me in trouble. Okay. Anyway, we're going to distribute. So I'm going to multiply the square root of 5 times 4. And I'm going to write that as 4 square roots of 5, because remember my coefficient goes on the outside of the square root of 5. Okay, now I'm going to multiply the square root of 5 times the square root of 20. Be careful, I have a negative here. So I'm going to have minus the square root of 5 times the square root of 20. Remember, the first thing I do is put them all under the radical, multiply, and then take anything out. So I can't simplify this first term, it just stays there. So this becomes the square root of 100. Now, is that a perfect square? Is there a perfect square in 100? Well, it happens to be exactly a perfect square, and this is 10. Now, I have a radical here. I have just a regular number, a constant they call that, right there. I can't add. I can't combine those together. So that is my answer. They cannot be added together. So there you go. Okay, let's do another one. Of course, it's going to get a little bit more complicated. How about the square root of 7 plus the square root of 2 times the square root of 7 minus 3 square roots of 2? Okay, now we're not doing the distributive property. What are we doing? FOIL. Okay, what we learned in chapter 9, we're now going to apply to square roots. So I need to multiply first, outside, inside, last. I'm going to change colors for this. How about pink? All right, so I've got the square root of 7 times the square root of 7. That's my first term. That's first. Then I'm going to do the outside 2. So I've got the square root of 7. So I'm going to add the square root of 7 times negative 3 square roots of 2. That's outside for FOIL. Then I'm going to do inside, which is going to be the square root of 2 times the square root of 7. And then I'm going to do last, which is the square root of 2 times negative 3 square roots of 2. So I have all 4 multiplication problems, and I'm going to work those all out and see if I can combine anything together. So here, this actually means the square root of 7 squared, which works out to be 7. I'm just going to finish that term there. Okay, now I'm going to multiply the square root of 7 times negative 3 square roots of 2. The negative 3 stays on the outside, and then I put the square root of 7 times 2 underneath. So now I'm going to have the square root of 14 underneath. Again, I'm going to multiply, put everything under 1 square root, and then I simplify. Okay, and then the last one is going to be the square root of, I'm going to have negative 3 outside, and I'll have the square root of 2 times the square root of 2. So it's being split up a little bit because both of these have a square root, so all those numbers go underneath, both of them. Okay? Now, what is 2 times 2? It's 4. And what is the square root of 4? Well, that is 2. So I actually have negative 3 times 2, which is negative 6. So that one took a little bit of extra work, so I'm going to write down everything else. So it's all in one straight line. Okay? Okay, now I have these 4 terms left, and I want to see if I can add anything together. Well, I can. I've got 7 over here, and I have negative 6 over there. So I'm going to combine those. 7 minus 6 is 1. Then I'm going to look at these two, and they both have the square root of 14. So I'm going to add them together. If there's no number in front there, just like if I had x or y, what is actually there that I don't see? A 1. So there's really a 1 here. So I have negative 3 square roots of 14, and I have 1 square root of 14. So negative 3 plus 1 is negative 2. Negative 2 what? Square root of 14. And there is my final answer. Do you see how it's important to write everything down? There are so many places in this whole process where I could make a mistake. Writing it down helps me to catch my mistakes. I want you to catch your mistakes so you get 100% on your test. Okay? All right. I'm going to give you some OIOs right now. One of them on adding. Let's see if I can find that. Number 1, so we're going to simplify, which is just a big general word for add, subtract, or multiply. 2 square roots of 7 plus 3 square roots of 63. And number 2, we have 4 minus the square root of 5 times 1 minus the square root of 5. Okay, so you can go ahead and pause the video and do those, and we'll come back in just a moment. All right, I'm going to change colors again, just because I can, and show you my work. Okay, so I want to see first, can I simplify any or factor out any perfect squares? Well, let's list the factors of 63. 7 I cannot, so I've got 1 and 63, 2 doesn't go in, 3 and 21, 4, 5, 6, 7 and 9. Aha! I just found a perfect square right there. So I'm going to write this down, carry it along, and then I'm going to have 3 times the square root of 7 times the square root of 9. Okay, so then I'm going to have 2 square roots of 7 plus, now this simplifies to 3. Now remember, all 3 of these terms are numbers are part of the one term. So I can combine them where I can. So 3 times 3 is 9. 9 square roots of 7. And then I'm going to add them together, which is 11 square roots of 7 because they both have the same square root. Okay, let's do FOIL over here. So I've got 4 times 1. That's first. Outside is 4 times negative square root of 5. Then that's outside. Inside is negative square root of 5 times 1. And last is negative square root of 5 times negative square root of 5. All right, let's start to simplify. So 4 times 1 is 4, sorry. And then I have 4 times negative square root of 5, so that becomes a minus. And 1 times anything is itself. And a negative times a negative is positive, and the square root of 5 times the square root of 5 is 5. All right, so let's figure it out. 4 plus 5 is 9, and if I don't see a number there, this is a 1. I can hear you guys in the kitchen, so then I get minus negative 4 and negative 1 is negative 5. So then my answer is 9 times 5 square roots of 5. Okay, well, to liven things up, for our word problem, I found some pictures. So this is going to be number 5. All right, let's see if I can find it. Documents. Okay, so this is a picture of the planet Jupiter. Look at how cool that is. I just can't imagine. It is gigantic. All right, so we're going to do a word problem that references that planet. So let's make this go away. Whoops. Alrighty, take it down. Let's find another picture.
There you go, Mitch.
Here's our second picture, and this is a picture of Jupiter and its distance to the sun. So I'm going to read the problem, and then we will write down that important information. Okay, so listen up. The orbital period of a planet is the time it takes the planet to travel around the sun. So that would be all the way around. You can find the orbital period P using the formula P equals the square root of d cubed, where d is the average distance of the planet from the sun. So the first thing we're going to do is simplify the formula and then find out what Jupiter's orbital period is. Okay, so that's the problem. let's go back here. This is number 5. What was important from what I said? The formula for the period is the square root of d cubed. All right? And that is the average distance. So d equals the average distance to the sun. And it's in AU, we call it. The dogs are barking. That's astrological units. Astrological units. Hi, Nicole. Thank you for helping.
Hey, stop it.
All right. So, simplify the formula. Let's do that first. Oh, and what do we want to find? Sorry. We're going to, 1, simplify the formula. And 2, we're going to find the distance to Jupiter. All right. So I've got d cubed. This is an easy one, isn't it? All right. That's an odd exponent, so I'm going to change that to the square root of d squared and d. So then I can take the d out of the radical, and I get d square roots of d. So the square root of d squared is just d. So there's my formula. And you didn't see this in the picture. I couldn't do that. So here's the sun, and here's Earth, and then here's Jupiter. It's huge. And the distance here is 5.2 AUs. I don't have room to write in the picture AU. Okay, so all we do is this. 5.2 square root of 5.2. Here's this is number 1, simplified formula. And number 2 is that. Okay, so if I was to work that out with a calculator, I would put 5.2 square root times 5.2, and that works out to be 11.9. Now this is years, apparently. That's what it says, years. AU. So it's the time that it takes to travel around the sun. Can you imagine? Almost 12 years it takes. Some of you are like 14, 15 years old. Excuse me, can you please stop watching the dish? It's very loud. Thank you. Some of you are 14, 15 years old. Almost your entire life, it has taken Jupiter to go around the Earth, the sun, one time. Pretty crazy. Okay, here is your homework. I'll write it here. I will also send it home in the email I'm going to send you. And it's this, and 47, 67, oh sorry, 47, 49, and 67. Okay, thank you so much. Have a great day. I will be getting back to you about your Chapter 10 test. I will update you about that either later today or tomorrow morning. So don't worry, we will figure out the Chapter 10 test. Thanks so much, and have a great day. Bye.